Okay, so now we're going to convert a full polar equation into a rectangular equation, no longer just points to points. So if you think about what we have here, we have r equals 6 cosine of theta. The fact that it has an r and a theta tells me that this is a polar, and we want to turn them into x's and y's in order to be rectangular. So one trick that we can do is we can multiply both sides of the equation by r. We're introducing a new variable, but it's the same on both sides, so it's still equal. So that gives me r squared is 6 cosine of theta times r, or you could put r in front, it doesn't matter. It's all the same thing. And we've got to start using some of these little formulas over here to get into terms of x and y. So if you notice right here, we have r squared. Well, one of my formulas is that r squared is equal to x squared plus y squared. So we're going to substitute x squared plus y squared in for r squared. Then I've still got an r and a theta over on the right side. So if you look over here, I'm saying, okay, where is an r and a theta? I've got two options here with x and y. I have 6 cosine of theta times r. That's the same thing, let me write that over here, as 6 times r cosine of theta. So I can replace r cosine of theta with just x. So that gives me 6x. Once you do a few of these, it becomes a little more clear what you're looking at. But once again, just know that you're trying to get everything into terms of x and y. At this point, really, if we're just trying to convert, I can tell you exactly what equation we have if we get everything onto one side. You think back to when we did conic sections, we have x squared and y squared. This equation is actually a circle. And if you were to graph the original in polar form, you would also get a circle. So we're going into these. Now they can be any shape, from a line, circles, we could have our cardioids. Any of these are going to pop up, but in order to see that, we have to get it into the familiar rectangular form.